70% moisture, 70% moisture, there's a solid material, but if you put it into the digester, bacteria makes biogas from the organic part of the feedstock and not from the water. It becomes liquid, more liquid. Use maize silage with 30% dry matter. In digester, you get about 13% dry matter, and that's mixable if you use the right mixing system. And with this knowledge, we designed this SemiDrive fermentation technology, and the result was we could drastically reduce the digestion volume, which means a lower footprint of the plant, a lower concrete costs, and lower mixing costs. Mixing is related to the digester volume, and make half of the digester volume. We will reduce the mixing energy demand to half of the wet fermentation energy demand. So we reduce the costs of investment and the costs of operation by using this technology. Side effect was that we could repower existing plants, just increase the capacity by changing mixing and feeding system. Next slide, Joseph.
Yes.
The slide, yeah. Oh, could you start the first video? What you see here is a sample taking from my own digester in my plant in Bavaria. You see that's quite thick material. You cannot mix this with a standard mixer. You need a special mixer for that. The material there was about 84% moisture. And the second one, Joseph, yeah. Thank you. The second one is in a plant in Denmark where we mixed straw with manure to feed the digester with this very thick material. That's also about 70% dry matter or 83% moisture. So seeing this material, you can imagine that it's not so easy to mix it, that you must find the right pump, design the pipes in the correct way, and of course use the right mixing system to get a stable operation of the biogas plant. Okay, we can join to the next slide. Yeah.
Yeah. Thank you, Dr. Hans. So as you would have heard from Dr. Hans that in summary, the technology, what we are discussing here is it gives you a lower footprint of the digesters. It gives you 50% almost power consumption on the digesters compared to conventional technologies of wet fermentation or plug flow. And also in cases like feedstocks like pressmud, you will have lower slurry coming out of the plant, or almost you can avoid the liquid being generated in the plant, where liquid disposal, slurry disposal is still a challenge in Indian conditions. And your water consumption can also be reduced drastically by using this specific process. So this is the main differentiation in terms of the technology. So now we go into the next section, which is on the potential feedstocks which can be used for biogas generation. So one of the potential feedstocks in India, also in sugarcane growing countries, is pressmud, or you call it as filter cake in some countries. So most of you from sugarcane industry know that pressmud is a byproduct which is generated during sugarcane juice clarification process. Pressmud has around, say, around 70 to 75% moisture and the dry matter of around 25 to 30% dry matter. This is a fresh pressmud consistency. So it depends upon when you are measuring it. But we normally for biogas always consider the fresh pressmud or stored pressmud calculation for estimating the gas yield and for designing the digesters. Having said that, pressmud or the sugar mills run for, let's say, depending upon the region in India, anywhere between 4 months to 7 months or 4 months to 6 months, depending upon the local conditions. So what happens, the biogas plant has to run for 365 days in a year. We can't stop the plant and start the plant, stop the plant and start the plant, because there is a biology which is there, and you could do that by running at lower capacities. But for a constant yield, gas yield, and for sale of the gas, you need a complete uniform load across the year. So for that, press mud storage is one of the very key fundamental requirements of operating the biogas plant. I would like to stress this again, because a lot of clients or customers who we still think, they probably think that press mud can be run for 6 months and the plant can be stopped and restarted after 6 months. But there is a way and method for storing the press mud. It is, of course, an investment, but this is the way most of the biogas plants across the world operate. And press mud storage yard has to be taken into your financial calculations, if you're working on the projects, because that's a very crucial part of the system for getting a consistent gas. And when it comes to the gas yield, if you store the press mud in the right way, depending upon the characteristics of the press, when you can generate anywhere between 90 to 110 cubic meter per ton of press mud. But again, this depends upon your press mud quality. So we have a specific slide on how to maintain test the characteristics and how can you estimate your own gas potential. So the next feedstock is cane thrash. Cane thrash, again, as you know, that it comes from the post the harvesting of the sugarcane. From each acre, you can get around 5 to 6 tons of cane thrash, which is left behind in the cane fields. Generally, what is done in some countries is the cane thrash is burned, because you need to have, it's a huge volume to collect. So cane thrash is burned in some specific applications, in some specific cases, and then you have cane thrash can be baled also. It is something which is happening in Indian markets currently, that cane thrash is being baled for selling at biomass. And if a similar thing can be done by baling the cane thrash, it can be used in a biogas plant in combination with press mud as a co-digestion feedstock, or as a standalone feedstock as well. Again, cane thrash is available only for 4 to 6 months. That's an account of harvesting time, which is the normal sugar mills running season. So it's very important, again, to store the cane thrash in a right way and use it in the biogas plants. And cane thrash, of course, requires a pre-treatment process in comparison to press mud. When it comes to the gas yield of cane thrash, the gas yield can go up to 330 cubic meter per ton of cane thrash. As you could see, cane thrash is almost 3 times more gas yield compared to press mud, but it has a special pre-treatment process involved in it to make it digestible, easily digestible. And there is another feedstock which is discussed quite widely in India now, because when we started before 10 years, Napier grass was not in the picture in Indian conditions. But of late, in the last 3-4 years, a lot of investors, they want to look at independent feedstock where they don't have to be dependent upon a specific feedstock or any industry to procure it. So Napier grass is one of the most talked about feedstock currently in India. Napier grass, as you know, is traditionally used for cattle feeds. There are different varieties of Napier grass, but there is special energy crops, specific breeds which can be grown as an energy crop for biogas plants. And Napier grass can be grown easily in dry and drought conditions as well. So when it comes to the organic content, the Napier grass, which is having a dry matter between 20 to 30% dry matter, can be used for the biogas plants. And as I said, there are different varieties. So the harvesting time and the time of using it, like all those factors have to be looked in very closely. And again, when it comes to Napier grass, storage and processing is very key, because you could feed fresh grass, but in practically it's not feasible that you can feed fresh gas all the time. So again, a storage and making a silo. When I say silo, it's more like making it a specific particle size and storing it in a proper yard is required for Napier grass as well, because Napier grass is something similar to energy crops used in countries like Germany, where they use maize for also local grass as an energy crop of feeding into the biogas plants. So there is a lot of experience when it comes to us, when it comes to handle grass type feedstock. And the biogas yield from Napier grass again can vary depending upon the dry matter content in the grass. So this again goes to the point of doing the correct gas estimation potential, because we more often than not come across a lot of variations in gas potential given by different players. So the best thing to find out yourself is to do a actual gas testing, which we will again, explain in the coming slides. And now I hand over to Hans to continue on the straw as a feedstock.
Straw as a feedstock becomes more and more interesting for biogas plants. Straw is not too easy to handle. The straw, we must shred the straw or pelletize the straw to get it mixable into the digester and get the biogas from it. Straw is always about 85% dry matter, and in this dry matter, about 90%, 85 to 90% is organic part, and only this organic part, of course, in the dry matter can be used to produce the biogas. With straw, it's very important to find a feasible way to collect, to transport, and to store it. Straw is always a feedstock which you get only during the harvesting season of, doesn't matter whether it's wheat or rice or even sugarcane or maize straw, but you must store it in the right way to have it available the whole year. The key is the pretreatment for digestion. That's the most important part of the preparing of the straw as a feedstock for biogas plant. On account of the high dry matter in the straw, it's very dry material. The SemiDrive fermentation technology is, from my point of view, the best way to handle the straw. I was working with straw as a feedstock in Denmark in a wet fermentation plant, and we had big problems to bring it into the digester, big problems to mix it in the liquid without any pretreatment besides shredding. And if you do it in the right way, you get about 15% higher gas yield than only shredding and trying to mix it into the digester. The gas yield depends on the type of straw. We have about 300 to 340 cubic meter biogas per ton of straw. This also depends on the pretreatment. I have tests with results of more than 400 cubic meters biogas per ton of straw. But in that case, we always must check the profitability. The pretreatment sometimes is quite expensive. Joseph?
Yeah. When it comes to multi-feedstock biogas plants, this is a very important concept which the market we hope will adopt in future in India as well. A biogas plant in general has to be a multi-feedstock plant. The reason being, depending upon one single feedstock over a longer period of time, is like, there is an amount of risk element involved in this. So when you design a biogas plant, the biogas plant has to be designed by taking a multiple or future feedstocks into context, and design has to be based on this. For example, feedstocks like pressed mud, Napier grass, cane thrash, poultry litter can be co-digested in a single digester. So initially, when we make a survey of the available feedstocks, so we must have an idea of what could be the potential feedstocks in future. But there are a few factors. If you're adding a straw or a corn stalk or a cane thrash, you need a pretreatment module. So pretreatment module is something which can be always integrated into the plant at a later stage if you want to add this specific, high dry matter feedstock which are difficult to digest. So in summary, the biogas plants is preferably should be designed as a multi-feedstock biogas plants, and the most of the experience we have comes from mono fermentation also on multi-feedstock plants, which is more, I would say, you need a special expertise in doing multi-feedstocks by knowing the mass balance of different feedstocks and designing the digesters. So whatever the plants we have done, most of them are multi-feedstock plants in the past. And the next slide here is about storage. If you recollect, while in the previous slides I was mentioning again and again about storage yards. because this is, I'm re-emphasizing because a lot of people tend to ignore this, and many vendors try to sell the solutions by not considering this just the equipment package, and to reduce the cost on the project side. But as an investor, you should always look at your whole value chain, starting from the storage yard up to the manure handling, the whole value chain of the biogas plant. So what you see here in the storage yard in the left is a press-mud storage yard from one of the plants in Brazil, where our technical team with Dr. Hans was involved in developing this project. So press-mud, again, since there are many sugar mill customers or potential customers here, so it will be interesting to understand that press-mud can be stored without any enzymes or anything, just the normal storage by doing the right compaction, and by doing knowing the proper know-how for doing that. So it's crucial to know how to store this. And what you see in the right is a feedstock storage yard for energy crops. So this is here maize and some grass is used. So you have to follow the similar pattern for feeding energy crops as well. So yeah, so this is just to show some sample storage yards, how it can be done in Indian conditions as well. And over to you, Hans, on the gas yield.
Yeah, we had very often discussion about the gas yield, and some people promise very high gas yields with special technologies and so on. But at the end, the gas yield depends on the organic dry matter in the feedstock, nothing else. That's the key. A higher organic part, higher gas yield. But each feedstock has its own characteristics. So the same organic dry matter in a feedstock can have much lower gas yield than the other. That depends on, for example, the lignin content in that organic. Lignin is not, from anaerobic bacteria, not digestible. So if you have a high part of lignin, like in the straw, you will get a lower gas yield from the organic part of the feedstock than, for example, in maize silage, where the lignin content is much lower, so you get a higher gas yield. That's the one aspect, and the most important aspect in the gas yield. And it doesn't matter whether your digester is round, is rectangle, is from gold or steel or something like that. That's not interesting for the bacteria. For them, only the organic matter and the digestion process define the gas yield. The storage of the feedstock influences that gas yield. If you do it in the wrong way, you will lose gas yield by composting processes, for example. If you store it in the wrong way, the silage in the wrong way, composting process on the surface happens, and you will lose carbon and lose energy. In the digestion process, the bacteria needs to make the biogas. They need microelements, macroelements to form the enzymes to produce the biogas. And so you must operate the digester in the right way. You get the whole gas yield, which is theoretically in that feedstock. But the gas comes from the organic dry matter. So there are several digestion tests or calculation modules to get the gas yield of several feedstocks. My experience over the last 25 years with this is make a biomethane potential test according to the German Engineers Association regulation, then you get a real number. And do it in the correct way. Only that is a real usable number for the biogas yield of a feedstock. Yeah. So why should we use the CSTR technology for the solid substrates? Bacteria don't have legs to go to their feedstock. So we must make a homogeneous mixture in our digester to bring the bacteria to the feedstock, to remove the products of the bacteria, the gas from the bacteria to outside of the digester. So a mechanical mixing is the most important part for a successful digester operation. It produces a homogeneous digester content, and homogeneous digester content means each part of the digester is working well. If it's not well mixed, you will get areas, big areas in the digester where there is no good process. So you reduce the capacity of your digester if you have bad mixing. It prevents sedimentation, especially with press mud with the high content of inorganics. You have the risk of sedimentation in the digester. This is prevented by a good mixing system. It also prevents floating layers. That's a risk, especially with straw as feedstock. You can get floating layers, which hinders the gas going out. And in the floating layers, there's nearly no biological activity. So you should prevent the floating layers. And the mixing promotes the discharge of the biogas from the digester. Therefore, nearly all biogas plants in Germany are mixed, have CSTR technology. There are only a few which have no mixer inside. That's the so-called garage type of digester, where you put the feedstock, the solid feedstock in the garage, close with a shovel loader, close the door, and spray a little bit of liquid on the feedstock and hope to get gas. I have some experience with such plants. Last year, I had a client who had such a plant with big problems. He asked me to buy it. He would give it to me for €1, but I didn't take. These plants will produce about 40% lower biogas yields than a CSTR technology. Joseph? Yeah, that's a flow sheet, very simplified PNID for a multi-feedstock plant. Similar to that, all the biogas plant for solids I made are designed like this. We have the feedstock storage yard. Of course, we have to prepare the feedstock. If it's silage, we just shred it, cut it, compact it, make the silo from it, and then directly we can do it in the feeding system. If we have straw, we must have a pretreatment for the straw. Depends on the feedstock, the pretreatment. Then we bring the feedstock with a shovel loader or a telehunter into a solids feeding system. It's just a buffer capacity and the automatic transportation system via screws or conveyor belts into the digester in a dry form. From the digester, we put it out with special pumping system to a separation system normally. And the separation system removes the not digested part of the solids and made solid digestate, solid fertilizer. And the liquid we collect in a process water tank. And from there, we recirculate liquid in an amount we need to keep the digester mixable. That we control by our system just to keep it mixable. And the excess water we use as a liquid fertilizer, storage in a lagoon for digestate, or spray directly to the land. And of course, the gas line is quite simple: gas conditioning, H2S removal, CO2 removal in India, and then producing the CBG. Yeah, let's a little bit discuss about wet and semi-dry fermentation. I also made some wet fermentation plants in my life. And wet fermentation is a good and clever technology for the right feedstock. For example, if you use liquid manure, liquid slurry from cows, for example, with 8 or 10% dry matter, or nearly 90 or more than 90% moisture, there is no chance to use a semi-dry fermentation technology. You should use a wet fermentation technology. But when we made the wet fermentation technology in Brazil for the press mud, we had to add liquid. In that case, we used spent wash in the season and water in off season for mixing it. And after digestion, it was a really high challenge to remove the solids, to recirculate, to reduce water, and to bring the digestate to the land It was blocking the spraying technology on the land for the spent wash. So therefore, we had to remove all the solids in the digestate. And to do this, we needed a really complex technology with separator to decant and so on. At the end, you will need, in comparison to the SemiDrive fermentation, double the digester capacity to get the same hydraulic retention time on account of the water. Using the SemiDrive fermentation, you reduce the digestion capacity, half of it, and then depending on the system to handle the digestate, especially with press mud, it's very simple to add ash, boiler ash, to produce a solid fertilizer as a fertilizer for sugar plants. In the wet fermentation, my experience is you will have about double the energy consumption in comparison to a semi-dry fermentation technology in practical operation.
Yeah, thank you. So as Dr. Hans was explaining you the advantages of using a semi-dry fermentation, which is again a CSTR technology. I mean, it's a digester with agitators, but capable of mixing high viscosity. So now we would like to look into this retrofitting of existing digesters. If you look at, especially in the sugar industry, there are many spent wash digesters which were meant to be used for spent wash digestion or currently not in operation because most of the sugar mills, especially in the northern part like in UP and even some parts in the Maharashtra and Karnataka, have gone for incineration boilers. So what has happened is the spent wash digesters are still in the existing locations, but maybe used for some other storage. The point here is we could use this existing spent wash digesters and retrofit with our specific process, and we can use them for feedstock like press mud, for example, in the sugar mill. So retrofitting is a possibility with this specific technology what we are offering. For example, if you take a digester of 32-meter dia and 8-meter height or above 8-meter height, we can convert this into a 200-ton press mud plant or a Napier Grass plant or even a straw digestion plant of specific capacities. Most of the spent wash digesters might have a much higher height, like it's not 8-meter, it might be 15 meters, in some cases even 20 meters. So what could be done in those cases is there is a way to use this additional space for gas storage or doing some modifications, and we can still use the digesters. So there is a possibility of customers having existing digesters, or if you have an old wet fermentation plant made up which is constructed using an RCC, still you could increase your capacity. For example, if you are having 2 RCC digesters of, let's say, 6,000 cubic meter, you can double the capacity of feedstock by retrofitting or using our specific process. Or you might have a digester which is using the normal agitators or submersible mixers with a lot of sedimentation problems and other challenges. So those type of tanks, digesters, can also be retrofitted to increase the mixing capacity and also to optimize the plant capacity in general. So these are some of the select references which has been set in the past many years. Dr. Hans will briefly go through these slides by not taking much time. So he'll take some time to go through these slides, and then we'll go to the next section. Over to you, Hans, again.
Thank you, Joseph. That plant is a plant in eastern Germany near Berlin. I was responsible for the design of that plant in 1996, 1997. And when the plant was finished, my client asked me to operate the plant and had a 10 years operation contract for the plant. The operation, I stopped operation 2007. The plant was designed for several feedstocks waste around Berlin. That time it was the biggest waste processing biogas plant in Europe with 1.3 megawatt electrical power. It was processing in the average about 40,000 tons of waste per year and some cow manure. The mixture was crazy. We had the source separated municipal waste, organic part of the municipal waste, of parts of city of Berlin. We had food waste from kitchen waste from restaurants. We had slaughterhouse waste like chicken blood. We had supermarket waste, so packed food from supermarket, where we had to remove the food if they couldn't sell it and it was old or damaged. We got all this material, and we had to remove the impurities, the packing material, the stones, the bones, the metals, and so on. This we did in the technology you see in the right picture. So it was a wet process to remove all the impurities of the feedstock to get a clean pulp for digestion in that wet fermentation plant. Next slide. That is one of the biggest biogas plants in Germany I was responsible for. That's a plant in Silo near the border to Poland. The plant, when we designed the plant in 2009-10, the idea was to make a mono fermentation plant for maize silage. Very big plant, about 1,400 standard cubic meters methane per hour. 2 technologies to upgrade the biogas, each 700 cubic meter per hour biomethane. The one is a water scrubber, the second is a pressure swing adsorption technology. And there are also CHP to produce electricity and heat for the plant and for grid injection. Joseph, next. So the plant was designed for maize silage, but in the meantime, they use a wide range of feedstocks. The reason is the availability of the feedstock and, of course, the costs of the feedstock. They have even maize silage, very simple to handle, to digest. They have grass silage, they have grains, they have rye silage, they have sugar beet residues, a very wide range of feedstock, what they get on the market and store in that storage yard you see on the right picture. It's a very big plant, very interesting plant, and very successfully operated. Yeah, next. That's the plant in Brazil. The plant was under construction when I contracted in 2010. And when it was finished, I was asked to optimize it. You see the 2 digester on the upper picture. One gas holder was brown, the other green. You see the brown was the first, the green was changed. The brown color comes from the dust in the air. And the picture down is the lagoon for the spent wash and the biological H2S scrubber we installed there. This was the first and biggest press mud and spent wash plant in Brazil that time. Let's take the next slide. The next slide is my own biogas plant in Bavaria, also designed as a maize silage plant when we constructed the plant in 2008. I could buy the plant in 2016, 2008. My company was constructing the plant and I could buy the plant 2016. So I'm operating this plant myself since 2016. In the meantime, we have a wide range of feedstock, starting with triticale silage, grass silage, a new plant, Sylvia, very interesting new feedstock, always covering the soil and very good yield on per hectare. I have clover grass, grain, sugar beet residues, also a very wide range of feedstocks. We have a very small digester, only with 870 cubic meter volume, but we produce 637 kW. This results in an organic loading rate, OLR, of 12 kilogram organic dry matter per cubic meter per day. That's a very high loading rate for a digester. Next. Starting 2018, I was asked to optimize the biogas plants from a Ukrainian biogas company. They constructed several biogas plants in the Ukraine and none of them was working well. and a little bit changing in the technology and in the operation and micronutrients addition, we was able to optimize all of these plants. And as a result, some of the client asked us to help them to extend the plants to make new biogas plant. That's one of the plants we made. What you see is the bigger of the 3 tanks is the new digester, constructed for 2.7 megawatt electrical power with the feeding system in front of it. The 2 digester, the smaller one, or the original one. In the meantime, the plant was increased from 1.2 to 3.9 megawatt with our technology. We made several others in the same design. In total, we made 5 very big biogas plants in Brazil between 2019 and 2022. According to the war, we must stop in 2022. Next slide. What you here see is the digester under construction with the mixer and the heating system, just to give a feeling how this is done. Next one. Yeah, Joseph.
So now we will touch a little about on the biogas purification process, which is hydrogen sulfide and CO2 removal. When you talk about feedstocks like pressed mud, Napier grass and straw, the hydrogen sulfide levels are relatively low, less than 2,500 ppm or 3,000 at the maximum. So for such process, you can use a hydrogen sulfide removal using an activated carbon or an iron oxide based media. But especially it comes to CO2 removal, it's also crucial technology because your methane recovery and methane slippage are critical parameters for your revenue generation. If you look at the purification for CO2, there are different technologies. Water scrubbing is one of the widely used technology in the in the past decade, but it was one of the older technologies. But a lot of plants are now moved to either a membrane solution, which is one of the latest technology, and there is amine scrubbing, which is again using a special chemical for removing the CO2. If you have an excess heat, for example, then you can use an amine scrubbing. And then you have pressure swing absorption. This is one of the technologies which is also widely adopted across many plants. And it's if designed and operated in a right way, it's also one good solutions, which is independent of water or any chemicals. But only thing is you need to do the right design where your methane purity and your methane losses should be optimal. In European conditions, that the methane purity is expected to be more than 99%, and the methane losses should be less than 1%, because you inject the gas into the grid when you supply to the oil marketing companies in India. Currently in India we have a 90% methane, but that's not exactly the right way. There must be soon a revision which should made that methane purity should be 96% in Indian conditions. And the critical thing is on your revenue generation, the methane slippage, it should not be more than 2-3% in Indian conditions. So the technologies in India have been modified according to this. If you look at membrane technology, there is a 2-stage membrane, there is a 3-stage membrane. A 2-stage membrane is never used in Europe or in USA. A 2-stage membrane is specific to the Indian markets or even some other countries perhaps. This is to reduce the cost, but also the quality of the gas required in India would meet a 2-stage membrane is what we understand from this 96 to 97%. So it's very important to choose the right purification technology and take the losses and the purity into context. In terms of power consumption, all this technology, what we have looked and worked on is almost all of them have a same power consumption. In overall, if you even square the amine, the power consumption is lower, but the biomass or the heating consumption is higher. But if you do all the calculations, you do the math, then the operational costs are more or less the same. But again, choosing the right technology is very important. And also when it comes to purification of spent wash, it is very important, especially because spent wash has a very high ppm of around 25-30,000 H2S in present in the gas. So choosing the right purification technology for spent wash is also very important. And we are also working on providing the solutions currently for some of the sugar mills here in the Indian market. So we have proven technologies which can be used for handling high levels of hydrogen sulfide for removal of this high hydrogen sulfide levels in spent wash. This is just to show some pictures, visualization of how a pressure swing absorption system looks like. This is actually one plant from Europe, for example. So there is the operation is based on molecular sieve is used as a media in this pressure swing absorption towers. That's the one of the PSA systems. And then we have a membrane-based biogas purification. So the membrane systems are here. The membranes are made. Special membranes are made for using in this. So like what you see like vertical pipes, where the membrane, based on the concept of the flow of gas, the difference in flow between CO2 and methane, the methane is collected and then CO2 is separated based on this. But again, for a membrane to be successful, the pretreatment of hydrogen sulfide is very important. So you should have the right quality of hydrogen sulfide, which is less than 5 ppm or even possibly lesser, to take it into a membrane system. So the operation of a membrane or a PSU or any CO2 removal is totally dependent upon the H2S levels and the right purification before the CO2. And so the project's execution, how do we do this? As Mr. Sachin was explaining in the beginning of the presentation, Shrijee has a licensing agreement with J&F Biogas in India for offering the digestion technology. So Shrijee, being an experienced EPC player, will front-end the projects and execute the projects in India. And the design and know-how will be provided by J&F. And Shrijee and the team is capable of handling multiple projects, and we have the bandwidth to take several projects at the same time, even larger projects with suitable strategic partnerships as well. So this is the model of project execution for us here in India. So that was the last slide about what we are offering. And here I would like to take this opportunity to shortly thank Shrijee team, J&F Biogas team, everyone who have been putting their efforts into make this webinar happen, and also thank Dr. Hans for joining from Germany. Over to you, Sachin.
Yeah, so Joseph, just to confirm, can you hear me?
Yes.
Okay, there are a few questions on the chat window. If you can just go to the chat window and see the questions. And then
I will stop sharing now so that I will go to the chat window. Got it. Okay, let me start some of the queries. Okay, there is the one question of what is the organic loading rate for multiple feedstock plants? But again, I think Hans, you want to take that?
To be honest, I'm not really interested in the organic loading rate. I'm more interested in the wash out and in the ability of the bacteria to work well. So I was operating biogas plants with waste with 3 kilogram organic loading rate per cubic meter per day, up to 15. Each is possible. It depends on the design of the plant. So there is no organic loading rate which is best for a feedstock.
Yeah, so in summary, what Dr. Hans is saying, see, your organic loading rate would depend upon the type of feedstocks and combination. So if there are specific cases, we'd be more than happy to work and share these details. And there is one question, what is the distinct requirements to be differentiated between a solid substrate and the liquid substrate? Well, I can take this answer. See, when it comes to liquid substrates, we have like feedstock like spent wash, paper industry waste, even manure can be or cow manure which has a high moisture content can be made into a slurry. And when we say our specific process, we normally recommend this process for solids which are feedstocks which are more than 20% dry matter in its original form. For example, Napier grass, press mud, straw, cane thrash, and so on. And there is a question from Shravanti Energy. So can we operate a biogas plant and a standalone press mud grass, or do we need to add any additional feedstock? Hans, you want to take that question?
Yeah. For me, it doesn't matter. The bacteria needs the carbon and they need some nutrients, then they can make biogas. I made biogas from wastewater from yeast industry, pure wastewater from yeast industry, pure wastewater from sugar industry, so that doesn't matter. You can use it in monofermentation for silage, for straw. You just must operate it in the correct way. The multi-feedstock is interesting to be flexible in the feedstock supply. There are three major points for the success, for the economical success of a biogas plant. One, of course, is the right technology. The second part is the supply of feedstock. Without feedstock, no biogas. And only the third is, of course, the experience of the operator team.
Okay, and just a follow-up question on Napier grass, because this is very important also, I feel, because in India, there is a lot of misunderstanding on Napier grass. So the question is, does Napier grass require a pre-treatment?
Napier grass is one of the simplest feedstocks we can use. When we harvest the Napier grass for biogas production, it's shredded and made silo from it. That's the only pre-treatment. You must shred it to harvest, and to shred it to get the silage, then you cover the silage. You can directly use it in the digester without any additional pre-treatment.
Yeah, so that's the one of the common questions we have come across. So basically what Dr. Hans is saying is we don't need any specific pre-treatment. The grass can be loaded specifically with our CSTR semi-dry process. The grass can be taken directly into the digesters. So that's one of the significant advantages of using this specific process. And there is one question on how much less is the footprint of CSTR, a CSTR digester compared to the standard conventional wet fermentation digester.
It's about half. Digester about half. Of course, the additional technology around is the same for the gas treatment and so on, and for storage yard.
Yeah, so basically it's almost 50% of the size, and your power consumption also will be, for the digester section alone, it will be 50% compared to a let's say a wet fermentation digester. In India, what is the minimum viable plant capacity is a question, one of the questions from Mr. Sanket here. See, in India, if you, the thing is like, if you're doing a very good quality plant, which is going to be operational for 20-25 years, then you should be looking at, depending upon the feedstock, if you take press mud, you should have minimum 150-200 tons of press mud in a day. If it's Napier grass, you need to have again 200 tons of Napier grass in a day. If you're looking at straw-based plants, you should be looking at around 100 tons of straw in a day. So this is the standard sizes with a very good quality technology without compromising on your storage yard, your plant heating, the quality of piping, the gas holder quality, and your purification system and so on, because there are always two stories, right? There is a cheap technology, there is a standard technology. So for a good technology which can be operational for 20-25 years, this is the minimum requirement. And also there was a question on pre-treatment part, and when it comes to the costing part, we would definitely take this, like if you could send the email to sales@shrijee.com on the projects. And then how to maintain the organic loading rate with multi-feedstock. I think this was answered by Dr. Hans already. And okay, there is a question on, okay, I'll give the, okay, what is the gas yield per ton of Napier grass versus press mud? How do you differentiate that? Hans, you want to take the question on gas yield difference between press mud and Napier grass?
As I told before, the gas yield, of course, is depends on the organic part of the feedstock. The Napier grass, when you harvest it, very often it's had only 17%, 18% dry matter. So then the gas yield is low. If you harvest it later, when it comes to 28, 30% dry matter, you will get about 150 to 170 cubic meter biogas per ton of Napier grass. Okay.
Then I would take one more question on the manure side, though there is a question from Dr. Sonal Garg from Carbon Circle. The parameters of liquid digestate slurry that decide the recirculation to the digester or a rejection as a manure. I think the question is, what are the parameters to be looked into the liquid slurry to check whether it can be used into the recirculation of the digester or used as a manure, is the question. I mean, how would the quality of the slurry coming out of the plant be determining to either take it back into the digester for recirculation or take it as a manure?
The recirculation is only on account of the mixing characteristic in the digester. As long as we can mix the digester without recirculation, of course, we won't recirculate. We only recirculate according to the mixing of the digester. If it's not mixable, we must dilute it with recirculation water. All the rest goes out to the as fertilizer.
Okay, there is one question on what are the parameters under which amine or chemical scrubbing is suggested. See, amine and chemical scrubbing is suitable if you have an excess heat or you have a very cheap source of heat, because this specific purification technology requires some heat for the process and not much of power. So, for example, if you have some biomass, excess biomass or cheaper biomass, then that could be one of the options to use an amine. Or if you're next to a process industry where there is possible to do this. And maybe one question, Hans, where you can take this is liquefaction of biogas technically and economically possible?
That's a very interesting question. I founded a company in Germany for liquefying biogas. The reason is we start to use biomethane as bio-LNG for fueling trucks, for example. And in that case, the liquefaction is a very interesting option to produce this fuel. But of course, the liquefaction is a quite expensive technology from the investment point of view and from the energy demand we need. It's profitable, very profitable under the European regulations. I'm not sure that it would be profitable in India. I cannot calculate this, but using a liquefaction instead of a compression of the methane, you can transport, of course, much bigger amounts. You can transport it with a truck. You can transport 20 tons, 20,000 kilograms per truck. So you have a much lower transportation costs for the liquid biomethane in comparison to the compressed biomethane. But the technology, we will start the operation of our liquefier mid of next year.
Okay, there is one question on whether it's feasible to collect the CO2 and sell this from the purification system.
That's exactly the business we do with the liquefaction of the biomethane. We liquefy the whole biogas, and at the result, we will get liquid CO2, selling it in Germany, especially for greenhouse fertilizing, and we sell the liquid methane as a bio-LNG for trucks.
Okay, and there is also a question on operational plans in India. So we are discussion with several customers and also in a process of hopefully concluding some projects soon. So that is our current status here in India. And there is a question on, well, this is a general question. Are there any operational paddy straw plants in India and are they successful? To answer to this, there are some plants which have been set up, but we don't have a clear results on this yet. On a paddy straw based plants as of today in India. And there is one question, how much water needs to be added to a Napier grass before digestion? Hans, you want to take this?
For Napier grass, we don't need water. No water demand, nothing.
So for Napier grass, basically we would not use any water. We would start the digester with standard cow dung and water and feed the grass into the digester directly. So that's the advantage with our process. And can palm oil factory waste can be used as a feedstock for biogas plant?
Palm oil industry is a very interesting industry for biogas. You have the palm oil mill effluent, the liquid one. This is like spent wash. You should use a wet fermentation system to make this. But the palm oil mills also have the empty fruit bunches you can digest in such a system like we have. And other feedstocks mostly which are not used in the palm oil plantation currently, like the fibers which are burned and so on. So palm oil industry is interesting, and a part of the feedstock is very interesting for our digestion technology.
There is one question on how do you maintain the gas generation during winter and rainy season? Probably that's related to the heating. Hans, probably you can take that query.
Yeah. So of course we need the feedstock to operate the digester. So we need the storage yard for the feedstock to feed the digester the whole year and get the energy the whole year. Digester temperature. The digester is operated always on the same temperature. At the end, it doesn't matter which level we use, between 30 and 55 degrees. We use a little more than 50 degrees centigrade. And this we keep the whole year constant by heating the system. And it doesn't matter where the outside temperature is -20, like in my plant in winter, or it's +30. We always keep the same temperature by heating in winter.
Okay, there is a question on payback, so I can take this. So what is the typical payback for this project? So for a very good quality plant, standard plant of feasible capacity, to take between 4 years, around 4 years time for the payback for the project. And okay, in respect to Indian context, which purification technology is preferable for press mud, cow dung, and straw? So for this, as we discussed during in the presentation, if it's a well-designed purification system, most of them are well suited. But if you want less maintenance and operations, PSA is one option. And if you want a compact container, if you are doing the right hydrogen sulfide removal, membrane is one of the latest technologies in the market. Always work with reputed players who are able to offer this. For example, because there are many vendors in the market, choosing the right people with experience is very important in biogas, but not only looking at the cost as a factor, but also the lifetime of the plant in general. So then how do you work on C5? Then do we have, okay, soft presentations, of course, will be shared. I think probably our team, Shrijee team, might also post this online that we would communicate. And there is one question on the Nira Bhima SSK sugar mill from Maharashtra. So volatile solids play a vital role in the generation of biogas. Storage of press mud is an issue where the volatile solids gets deteriorated after a specific time. What precautions should be taken for proper storage of press mud?
I didn't understand the question.
The question is, how do we store the press mud in the right way? Because there is a lot of gas losses, the volatile solids which get decomposed.
The way to keep the energy in the press mud is lactic acid fermentation. And that happens if we compact it in the right way. With the lactic acid fermentation, we change a part of the rest of the sugars and so into lactic acid. This drops down the pH and stabilizes the press mud. Same process like in the maize or corn silage, doesn't matter.
Okay, so the answer is using the right storage methods as we were showing in the presentation. So that's very important to work with people who have already experience of storing it and operating it. So there is one question, how do we, something related to the same query, how do we prevent degradation or composting of press mud during storage? Is hydrolysis of press mud components like cellulose, hemicellulose required before feeding into the digester? I think he's referring to the hydrolysis of feedstock before feeding into the digester.
Yeah, for press mud, for sure not. Hydrolysis will happen in the digester parallel to the biogas production. If I put the hydrolysis as a special process in front of the digestion, hydrolysis produces gas, produces H2, produces CO2, and you cannot use this yet. So with hydrolysis, you always will have a loss of energy. I'm not a fan of a hydrolysis, and the hydrolysis systems are very difficult to handle the corrosion problems there.
Okay. So what's the normal processing of handling the digestate after the gas digestion? Maybe I can take this question. So when it comes to processing the digestate, it depends upon the location of the plant. Normally it is used as a manure. You have solid manure and the liquid manure which is generated post the separation in a decanter or a solid liquid separator. So depending upon solid manure, of course, can be stored and if required dried. Sun drying is the easiest option, unfortunately, because other options are quite expensive and energy intensive. When it comes to the liquid, it's a challenge. A lot of people think that liquid can be sold as a manure, but from our experience, selling liquid manure is not that easy because the farmers have to adapt to it. The best thing is to spray it on the fields. Again, in the Indian context, the fields owned by the farmers are quite, the land whole held by the farmers is normally very small compared to countries like Brazil and Germany, where you can spray in a big farmer's field. So that's the reason also we are offering the specific process of minimizing the liquid slurry generation, because what at least I estimate is that your cost of transportation of the liquid per cubic meter outside your plant will become expensive in Indian context if you're not able to sell the liquid slurry or give it to the farmer. So disposal cost will be a big operational cost in future when we have many biogas plants. So it's better to recirculate or use it the right mass balance or the right technology for handling the digestate. And there is a question from Narmada Sugar. What is the best technology for purification of raw biogas in case of spent wash? So in our experience, we would say biochemical, that to biochemical with right experienced companies who have this experience of doing it over several years, because H2S spent wash levels are quite high, and we have good experience now of working with these high hydrogen sulfides. So we could offer a solution for this. So it's crucial for offering this. And when it comes to the other process, you always have to, there is also chemical scrubbing, but you need to see the operational cost. So you have to see the OPEX of the plant, or always in a biogas plant, one should look at the operational cost over a period of 15 to 20 years. You might invest, let's say, 20% extra into the plant or 20% extra into pre-treatment or a purification, but always look at your payback over a longer period of time. This is what we keep telling our customers, because there is always two options. There is the cheaper option and there is a other standard option. But if you look at the OPEX, the OPEX should be the one of the main parameters in combination with the CAPEX. And then let's see. What is the digestion time for Napier grass? Hans, 30 days?
There is no digestion time for Napier grass. There is a hydraulic retention time. Bacteria needs to keep in the digester, and that's not depends on the type of feedstock, but only on the biology in digester. So Napier grass is the same than maize silage, grass silage, something like that. It doesn't have a special digestion time. We design for a average hydraulic digestion time in digester of more than 25 days, just to keep bacteria in.
Okay. So then how much gas yield does a maize silage give per ton? That's probably, what you can, you can take that. What is the gas yield from maize silage?
The average gas yield of maize silage in Germany, with the quality of maize in Germany, will be all over the world the same, I assume, will be about 210 cubic meters biogas per ton of standard average maize silage.
Okay. Are we producing CBG plants as per biofuel policy October? So there is a question on the Satat scheme. So see, the question is not quite clear, but see, when it comes to the Satat scheme, there is the standard of gas quality which has to be maintained. So it is very important to do this, where we should target more than 95-96% methane. And there is one question asked related to a thermophilic or a mesophilic digester, which is best for energy crops like paddy, straw, silage, and Napier grass.
I know all about the discussions about thermophilic and mesophilic digestion, and I told the students when I did my PhD. In the meantime, I don't believe in thermophilic and mesophilic. I was operating biogas plants between 30 and 55 degrees centigrade each temperature over long years, and each temperature worked well if we did it in the correct way. So I would operate the biogas plant mesophilic, so lower than 40 degrees centigrade, if I have no heat for heating up the digester and have a very liquid feedstock where I need a big amount of heat. That's only a question of the profitability. If I have a feedstock like silage with high energy density and self-heating in the digester by the biological process, I must go to higher temperature, to thermophilic, to avoid cooling down the digester and to keep constant temperature. So it depends on the situation. For me, thermophilic or mesophilic, what is better from the biological point of view doesn't matter.
Okay, the answer is it depends upon how you operate and the local conditions. So technically, it's thermophilic or mesophilic is just a definition in operate is what matters. And there is a lot of questions again on Napier grass. So what we would say is when it comes to harvesting of this grass, there are many questions. It depends upon the quality on the variety of grass you're using. So we would always say the customers to choose the right variety of grass based on your local conditions, and also do a characteristic test on a biomethane potential test if possible to determine the gas yield, because there are always a confusion in the Indian biogas industry on gas yields of different feedstocks. We have seen there are some vendors who set a very higher expectations of gas yield, who give quite high gas yields, which in practically might not be realistic. So one should be careful with determining the gas yields of different feedstocks by closely studying the characteristics and also by doing some practical tests on them. And that was a common question on Napier grass and volatile solids purification technologies we have added, and the presentations of course could be shared once that is, you could always request the Shrijee sales any queries related to that. Yes, and Sachin, how much time we have? Can we take another?
Maybe another,
2-3 questions?
yeah, just 2-3 questions because we're already at 3:45, Joseph. So maybe last 2 or 3
Okay,
questions.
one more question. Yeah, okay.
Flower waste is interesting.
Okay, flower waste. Hans, you want to take this? Can flower waste be used?
Yeah. The waste from flower, I'm using myself this waste from cleaning the wheat, for example. It's a very interesting feedstock. It's a dry feedstock. With this feedstock, you control the performance of your plant, very easy to handle in our system. I think it will be same in India with rice husk or something like that. Could be interesting feedstock for biogas plants. And I saw a question about cassava residues. Cassava residues are interesting feedstocks, but we must discuss how to organize it over the whole year on account of the harvesting seasons. It's more difficult than press mud storage.
Okay.
Okay, over to you, Sachin.
Okay, well, thank you everybody for your enthusiastic participation. We really appreciate it. I apologize if we were not able to get to some of the questions. As you know, we are already 20 minutes over. And so again, apologies if we were not able to reach your question. Shrijee is available. We welcome your inquiries. We can be reached at sales@shrijee.com. That's sales@shrijee.com. So thank you to both our experts, Danke, Dr. Hans. Thank you very much for making the time. And Joseph, as always, thank you. It's very nice to listen to you. So thank you, everybody. And stay safe, stay dry, those of you who are in Mumbai.
Okay, thank you. Bye-bye.